Hey, this is the third video of lesson two. My bad. I had to stop for a minute. So we get negative 3 pi over 10. And then to put this in the calculator, if you don't want to put the negative, it's cool. Just do 3 second caret to get that pi. Then divided by 10. Yeah. And just put that in the calculator and then slap a negative on it. And don't forget to round according to what your homework wants. Okay, if we keep going, we're trying to convert these strange words to radians or pies. Well, this is a trick because you already know how to do this. Okay, let's think about this. This is not in degrees, so I can't do that whole multiplying by pi over 180 because I don't have that little degree symbol that can cancel. So, darn, we're going to have to use our brain. Okay, what does rotation mean? Rotation means a circle. So let's think about this. When I draw angles, I start at the x-axis, and one rotation, let's see if is this one rotation? Nah, I gotta go all the way around. That's one rotation. So one spiral is equal to one rotation. And when I go all the way around, I land at 360 degrees, or what else is 360 known as? It's known as 2 pi. So one rotation is 2 pi. If you wanted to know, 2 rotations would be 4 pi. If you wanted to know, 4 rotations would be, why did I skip that? Oops, my bad. 3 rotations would be 3 times 2 is 6 pi. So rotation means 2 pi, basically. And one rotation is 2 pi. Okay, let's look at this sucker. It says 3 revolutions. Now, hold up. In math, revolution and rotation are kind of similar. For right now, they mean the same thing. So revolution means we still start at the positive x-axis and we go all the way around once. That's a revolution. Kind of like when the Earth, spins on its axis. That's called a revolution. Yeah. Okay. Or, yeah. So 3 revolutions. Well, 1 revolution is 2 pi. If I go around again, it's 4 pi. If I go around again, whoops. If I go around again, it's 6 pi. Okay, so revolutions and rotations are kind of the same thing. Okay, let's look at, they mean spirals. Let's look at I. It says half a rotation. Okay, well, if one rotation is all the way around the circle, 2 pi, what's half a rotation? It's just the top half of the circle. How much is half of a circle? How many degrees is half of a circle? Well, we land at 180. And 180 is 1 pi. Okay, so half a rotation is just 1 pi. But we don't write 1 before the pi because we're grown-ups. So 1 full rotation is 2 pi. Half a rotation is just 1 pi. All right, let's go to 5/7 of a rotation. What in the who? What? Okay, so since 1 rotation is worth 2 pi, we can kind of pretend that's my unit of conversion. And we can multiply by pi over 180 or some kind of that. But for us, instead of pi over 180, we're going to multiply by 1 rot over 2 pi. So let's see here. We have 5/7 rotation And we're going to multiply it by 2 pi over 1 rotation. And the reason we're putting the rot on the bottom is so that the rot on the bottom will cancel out with the rotation on the top. So now all we have to do is figure out what 5 times 2. Yeah, let's not put the pi yet. Let's go ahead and divide by this 7 because 7's underneath. So divide by 7. And let's figure out what that is. We might have to press math enter. But it should give us 10 over 7. And see how the pi is still on top? We say 10 pi over 7 radians or whatnot. So just like we multiplied by pi over 180, here we said 2 pi was 1 full rotation. All right, let's go again. Let's talk about a circle and how to find just a piece of this outside, like how long, say, the crust is on a piece of pizza. Let's look at this. It says we're talking about pizza. It says Timmy ate almost all of his pizza. The radius is 6 inches. So that means halfway from the center out is 6 inches. Oh, yeah. Okay. And then it says the theta is 5 pi over 4 radians. What in the hula? What? Okay. What? Okay. We don't know how big that is, but it's okay. It's actually super big. 5 pi over 4 is, if you think of the unit circle, or if you look at your sticker, we look at our sticker, pi over 4 starts here and goes, my bad, 5 pi over 4. Goodness, look at this. That's a big old piece of pizza. So we start here and wrap all the way around. Okay, so from here all the way around is 5 pi over 4. And when I say from here all the way around, I mean the angle that is created up in there by all those pizza slices. So from start to finish, this whole piece of pizza, all these pieces of pizzas make up 5 pi over 4. It was a couple of pieces of pizzas, but oh well. Anyway, so we want to know, what is the arc length? Okay, arc length is what you think about. Arc looks like this. Length is how long it is. Bam. So we're trying to find how long is the crust. So this junk on the outside, like the stuffed crust, the bready part, we're trying to figure out the crust. And that crust, we call it the letter S. And we don't know how long that sucker is. Okay, well, there's a formula. The formula is S equals R theta. And theta must be in radians, or another way of saying radians is pi's. Okay, so let's use our formula. We got S equals R theta. S is the thing we don't know. It's the crust. So question mark. R is that, where's the radius? Radius. 6 inches. Times the theta. Our theta is 5 pi over 4. And we're cool to use that. We're good to go. Because your theta has to be in pi's whenever you use this little formula. We can never use a degree. Okay, so let's multiply this. We're going to do it the same-ish kind of way that we were doing this kind of hoopla. Yeah, where we multiply the top and then divide by the bottom number, but don't touch the pi. Okay, same thing here. It looks kind of scary, but you're going to do 6 times 5 divided by 4, and then we're going to slap a pi on it. Okay, so let's do that. 6 times 5 is 30 divided by 4. Oh, gosh. Math, enter 15 over 2. Okay, so I think you get 15 over 2. Yeah. So my S, we just got it. 6 times 5 divided by 4 is 15 over 2 with a pi on top inches. Or if you wanted to put it in the calculator, you could put it in the calculator for the decimal. And then just make sure you pay attention to what they want you to round to. Okay, so again, the angle is on the inside of the pizza. The crust is on the outside. Okay, and the angle describes how fat that slice of a pizza is. This slice of pizza is massive. Okay. All right, let's go again. We're still going to use the same formula, S equals R theta, but instead of talking about a two-dimensional circle, like a pizza, let's talk about a three-dimensional circle, as in a sphere. And when I say a sphere, I mean Earth. Okay, so let's think about Earth. Let's pretend that Seattle has the coordinates, GPS coordinates, of 47.4 degrees north latitude, comma, 122 degrees west longitude. And then it says San Francisco is at 37.4 degrees north and 122.5 degrees west. This is how people in the military find where they're going. You know, remember you always watch movies and it says, send me your coordinates. This is it. And this is actually latitude and longitude. Okay, before we talk about the rest of this problem, let me explain what latitude and longitude is. Okay, latitude is if I were to take whatever this thing is and I would cut it latitudinally, like side to side. So here's my shape. Yeah, okay, and here's, okay. So latitude means side to side, okay? And let's say I want our latitude start right in the center at the equator. You get what I'm saying? Okay, so let's say this is the equator. And it's actually at 0 degrees. Okay, the next latitude, oh gosh, up. Okay, let's pretend that's the next latitude up. The next cut side to side is at 10 degrees north because we're going north. Okay, now let's try a south. Let's say I go to the 1, 2, third cut down. And remember, these are latitudes. So, this first cut down would not be negatives degrees. It's just 10 degrees south, then 20 degrees south, then 30 degrees south. Yeah. So latitudes are when you take the earth and you cut side to side. Yeah. And as you go up, we increase by 10 degrees for each latitude. And as you go up, it's north. As you go down, it's south. Okay? Now let's talk about longitudes. Longitudes are when you cut up and down. Yeah. And where we start our longitudes is at the prime meridian. And the prime meridian is actually not at 0 degrees. It's somewhere else. And it has to do with some political things. But anyway, the prime meridian is going to be at 0 degrees. Yeah. Okay. But then each time we take a vertical cut into the earth, oops, there's another longitude. And there's another longitude. And there's another longitude. You get what I'm saying? Okay, I'm going to stop using this because it's all greasy. Okay, so anyway, here's my earth. 0 degrees is at the equator. The next side-to-side cut is 10 degrees north. then 20 degrees north, and so forth and so forth. As we go south, it's 10 degrees south, 20 degrees south, 30 degrees south. So we don't deal with negatives when we're talking about GPS coordinates. Now let's talk about longitudes. 0 degrees for longitude is at that prime meridian. And our prime meridian is actually not at 0 degrees because politics. All right. As we go to the right, the first curve we cut into that fruit is at 10 degrees. And since this right side is north, south, east, that's 10 degrees, east. Then the next cut is 20 degrees east. Then the next cut is 30 degrees east. You get the point. And then as we go left, it's west. Okay, so now that we have a basic understanding of latitude and longitude, let's go back to this picture. So we're talking about the Earth. Here's the equator. Okay, let's think about where Seattle and San Francisco are. Let's say this is the America. What? Okay, let's pretend that's America. Okay, Seattle is way up here, right? Yeah. San Francisco is actually south of it. It's in California, and that makes sense because it's on the California side. San Francisco is in Washington. Okay, and if you look, it says Seattle is at 47.4 degrees north. San Francisco is at 37.4 degrees north. Okay, and it says use the difference in latitudes. Okay, so that's important. The latitudes, remember, are the side to side or the north, south, east, west. Okay, so we're going to, my bad, not north, south, east, west, just north and south. So we're going to subtract these norths to find the angle of this wedge that is created when I cut out Seattle and California. So let's say, no, I can't do it. I don't know how to do it with this piece of fruit. Okay. So let's subtract our angles, 47.4. So we're 10 degrees away from each other. Seattle is 10 degrees north of California. Or if I were to cut into the earth to the very center, with Seattle and California being the crust, that angle created, that three-dimensional angle created on the inside near the crust would be 10 degrees. So these are 10 degrees different from each other. However, we're going to use this S equals R theta, but let's remember theta has to be in pies. This ain't in pies. Okay, so let's convert. We're going to say 10 degrees north. Remember our conversion factor for degrees to pies or degrees to radians? It's pi over 180. That way the little degree can cancel. Okay. And then we type this in the calculator, or we can use that rule of zeros where 1 0 over 2 0. Anyway. Okay, so this should become 1 over 18 with a pi on it. Or, since we're grown-ups, we'll say pi over 18 radians north. So this little chunk, if I were to cut out this slice, this piece of earth, the angle would be pi over 18 degrees. Okay, so we are going to now use theta equals that pi over 18. We are not going to use that degree. All right, let's keep reading. It said use the difference in latitudes. I just did. Okay, to find the distance between the cities. The distance between the cities, let's think about this. This is a sphere, an Earth. And even though we think that when you drive from California or from San Francisco to Seattle, you might think that you're driving on level Earth as you're driving on the highway. But you know what? You're not, because we're not flat earthers. Earth is curved. So when you drive from San Francisco to Seattle, you're actually driving on the curvature of the Earth. We just can't feel it curved. Okay, so the distance between the cities is the S from S equals R theta. It's like the crust of the Earth. And we don't know how long that crust of the Earth is, or how the distance that we have to travel. Okay, however, we do know S equals R theta. So question mark, because that's the crust of the Earth, or the distance of the Earth, we don't know. R is radius of the Earth. Let's see. Distance between the cities. The radius of the Earth is 3960 miles. So my radius is 3960 miles. I don't know why I put it in parentheses. I was paranoid. Okay, then my theta is this pi over 18 we're using. Yeah. And then we're going to multiply it. And let's do it without the pi and then with. So let's say 3960 divided by 18. Okay, so we get S equals 220 pi miles. Or let's put it in the calculator. S equals 220 and then second caret. Hey, 69 or 691.15. As a whole number, let's just whole number with a W. Let's say it's 691, just 691 miles. All right, so the crust of the Earth, or from Seattle to San Francisco, should be about 691-ish miles. Okay, if we wanted to know the exact answer, we would use this 220 pi. Yeah. If I wanted a decimal, I'd round it to what they told us to round it to. Okay, now let's talk about complement and supplement of an angle. All right, first off, complement. Oh, I didn't write the rest of the word. Oh, the rest of the word is up here. Complement. It's not like when you compliment somebody and tell them they're pretty. That's compliment with an I. When you tell somebody they have nice shoes, that's with an I. This one's an E. Okay, anyway. Complement means it adds to 90. Supplement, the way I remember that, is supple. Supple is like when something has more. Yeah, like or if you want to supplement your income, you want more money. Okay, anyway. So supplement means you have to add to 180. And the way I remember those is supple is bigger, so I have to add to the 180 because the 180 is bigger than the 90. Okay, that was lame. You don't have to remember that way. All right, let's see. If I give you the angle 43, the complement is whatever plus 43 gives you 90. Okay, well, we can go bass-backwards, and instead of talking about adding, we could go bass-backwards and subtract. So it's like we're saying something plus 43 equals 90. And instead of trying to sit here and guess, we could just go bass-backwards and say 90 minus 43 equals the complement. So let's go. 90 minus 43 is 47 degrees. That's the complement. Okay, now let's look at the supple. The supplement. What it's asking, what angle plus that 43 gives you 180? Well, instead of thinking that way, I'm not good at adding up. So I'm going to go backwards. And I'm going to say 180 minus 43 is going to give me my supplementary angle. So 180 minus 43 is 137 degrees. Heyo, let's go to this next sucker. 4x to the what? This says 4x degrees. That's a little degree symbol. All right, instead of thinking, what plus 4x gives you 90, we're going to go backwards. We're going to say 90 minus 4x degrees will give you the angle we want. What? So usually, when we turn it around, we say 90 minus the angle they give us equals our answer. Yeah. And our answer here is not going to be anything crazy. It's still just going to be 90 minus 4x. Yeah. 90 minus 4x is our whole answer. Because there's an x and we don't know what x is. Okay, let's look at the supplementary. Instead of saying something plus 4x equals 180, I'm going to say 180 minus my something. So 180 minus 4x. Hey, that's my supplementary. Okay, now let's switch it up and make pies. Okay, let's say I have pi over 5. Well, I cannot say 90 minus pi over 5. We cannot do that because 90 degrees is a degree and pi over 5 is a radian. They're two different units of measurement. Two different things. So what else is 90 in terms of pi? Let's see. Earlier, remember back in the day we said 1 pi was, or what did we say? We said 2 pi was 360 degrees. Yeah. Okay. So what's 1 pi? 1 pi is 180. So that's the thing we need to add to for this supplementary is we need to not add to 180, but just to pi. Okay. Well, if 180 is pi, what's 90? A snack. It's half a pi. Okay, so this sucker we have to add to pi over 2. All right, let's go. So instead of saying 90 minus our angle, because our angle was in pies, we're going to say pi over 2 minus our angle. Then common denominator, I think some elementary school teacher taught you cross multiply. So you multiply this first fraction by 5, because that's the other denominator. And then you multiply the second fraction by 2, because it's the other denominator. Yeah. Okay, and this makes 5 pi over 10 minus 2 pi over 10. And then on the top, we just subtract the big fat number and leave the pi there. So 5 minus dos trace pi, always over that same denominator, 10. All right, let's find the supplement. Okay, usually we take 180 and minus the angle they gave us. But we're not going to do that here. Why not? Because they gave us a pi. So we can't subtract from a degree. That's like subtracting, that's like saying 40 inches minus 2 centimeters is 38 inches. That's not a real thing. That's not true because they're two different units of measure. So we cannot say degrees minus a radian or pi. Instead, we're just going to say the radian equivalent, or whatever pi is, which we said it was 180. Yeah, 180 is pi, minus pi over 5. Okay, for the common denominator, let's include my good friend Juan. and then multiply by a 5 so I can get both of the bottoms to become 5. So we get 5 pi over 5 minus, oh, this guy is good to go. We don't need the pi over 5, but I might need my good friend Juan on the top just to help me count. 5 pi minus my good friend Juan pi is 4 pi, always over that denominator. Yay. Okay, I don't think we're going to do this next one. Let's go ahead and go to something called cofunction. Okay, so we have these things called functions and cofunctions. And it's very easy to get this word cofunction confused with reciprocal and what's another one? Coterminal. Yeah, okay. So when I say function, the parent functions, or the 3 basic functions that we're talking about, are sine, secant, and tangent. What? I know, weird, right? Okay, so we're going to call these functions. Technically, sine and cosine are both functions, but cosine has a special name. Okay, so anyway, sine, secant, and tangent are functions. Cofunctions are these with a co in front of it. So cosine, that makes COS, or cosecant, what does that make? CSC. Okay. What about cotangent? What's his abbreviation? Cot? Yeah. Okay, so we're going to say that functions are the sine, secant, and tangent. It's like the original word, sine, secant, tangent. But then once you put a co on those words, cosine, that means you're finding a cofunction. Cosecant, that's a cofunction. Okay, the other thing we need to know about cofunctions is they add to 90. They're complementary. So they add to 90, or if you're dealing with pi's, that's pi over 2. Okay, so let's see here. I gave you a table with mixed pieces. So let's say I have sine. What's the cofunction of that? Well, first you put a co on it, cosine, but that's not how we write cosine, is it? So it's just COS, and then whatever is up in these parentheses better add to 90. So let's see here. What plus 30 gives you 90? 60. Yay. Okay. And the reason that is because 90 minus 30 equals 60. So that's where I got this 60 over here for the cosine. Okay, let's look at the next one. I gave you the Bass backwards. Okay, we say this is cotangent. Tangent. Okay, so if it's the cofunction, its function is whatever that word is without the co in front of it. So this stands for cotangent. Ours is just going to be tangent. And then let's subtract 90 minus 47, 50, 43. And I think that gives you 43. So tangent 43 degrees is the cofunction of cotangent 47. Because they're both the same word, tangent, cotangent, only one has a co in front of it. And our angles add up to 90. All right, let's go to secant. Secant, which word means secant with a co in front of it? Well, let's see. Cosecant, we don't abbreviate it that way. We abbreviate it as CSC. Okay, so CSC. And then we need to take this pi over 6 and subtract it from 90. What? But we can't do that. Why not? because these don't have the same units. 90 is a degree, pi is a radian. So I can't do 90 over minus pi over 6. Poop. So we use his equivalent, his conversion. 90 is the same thing as pi over 2. All right, let's do this. Pi over 2 minus this pi over 6. Okay, we need a common denominator. I need this bottom left fraction, the bottom of the left fraction, to become a 6. What can I multiply? 3 and 3. So this becomes 3 pi over 6 minus 1 pi over 6. Let's see if we know what that is. 3 minus 1 is 2 pi over always that 6. And then I'm pretty sure you can reduce that. You can divide by 2. So it just gets you pi over 3. Hey-oh, that's our cofunction. CSC pi over 3. All right, let's look at this next sucker. It says cos. Well, that is the word cosine. So what's this word without the co? Just sine. Okay. And then we have to figure out what other angle adds with this pi over 12 to give me 90 or pi over 2. Well, we're going to do the same thing. Instead of adding, we're going to think about subtracting. Pi over 2 minus pi over 12. Common denominator. I need to multiply by a 6 because that way my bottoms will both be 12. Okay, now let's see if we can subtract. I'm going to have 6 pi minus my good friend 1 pi. 6 minus 1 is 5 pi. And then both of these denominators are 12. So the cofunction is cosine pi over 12. The function, the cofunction of this cofunction, whatever, is sine 5 pi over 12. So these two suckers are cofunctions. Yeah. Okay, and if you're wondering why the heck we're doing this, cofunctions are equal. So it could save us time in the future. For example, let's see what this sine 30 is. First, let me get in degrees. See how sine 30 is 0.5? Let's see what its cofunction is. Cosine 60. It's 0.5. That's because cofunctions are equal to each other. Not the words. The words are not equal. The words are different, as you can tell. The angles are not equal. They're different, as you can tell. But what they represent from the opposite over adjacent, adjacent over hypotenuse, that's the same. Yeah. So on a triangle, sine 30 and cosine 60 pop out the same answer. Just like tan 43 and cotan 47 should pop out the same answer. Let me try. Cotan, remember we have to do 1 divided by tan, so it's funky. Hey, and look, those are equal. Okay, so that's the purpose of cofunctions. They could save us time. Okay, let's look at tan x degrees. Well, what's his cofunction? Well, it's definitely cotangent. So how do we abbreviate that? We say COT, okay? And how do we write its angle? Well, we say 90 minus x degrees, or if it asks for it in pies, the equivalent of 90 was pi over 2. Remember that? 90 pi over 2. Okay. So we would say pi over 2 minus x, and there would not be a little degree symbol in your hair. Okay, so those are cofunctions, and the reason we talk about them is because their values are equal. So sometimes when we're doing our work, we might save 30 seconds by using that trick. Okay, so cofunction, it's all about that 3-letter word and the angle's adding up to 90. Now let's talk about coterminal. Okay, and when we were talking about cofunctions, remember the word function is the sine, secant, tangent. So cofunctions have co with these three-letter words. As in, cofunctions deal with the sine, cosine, tangent, blah, 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 SOHCAHTOA, that kind of thing. Sine, cosine, tangent, secant, cosecant, blah. Okay, coterminal angle is not dealing with the sine, secant, cotangent, tangent. It's talking about just an angle. Okay, so let's say I give you the angle of 32 degrees, and I want to know something called a coterminal angle that's positive and negative. Okay, I don't have my little Temu slider, but I think I can do this. Okay, coterminal angles are where you add or subtract 360 degrees, or its equivalent, or adding and subtracting 2 pi. Okay, and let me show you what a picture of coterminal would be. Let me slide maybe down here. Okay, coterminal means you draw your first angle. Okay, so let's draw my first angle. Let's say from here to here is my first angle that they give us. Angle. Okay, this crookedy line that we drew, that's going to become the hypotenuse of a triangle. Either way, this crookedy line, it's called the terminal side. Terminal side. So when it's asking for a coterminal angle, it's saying, okay, what's another angle that has the same terminal side, that shares the same terminal side? Kind of like cofunctions share the same three-letter word. Sine, cosine, tangent, cotangent. They share the same three-letter word. That's what co means. You share in your duties. Like if you co-parent, you share in your duties. Okay, so I want to find another angle that shares the same terminal side. Okay, well, if I want a positive one, I can think about, okay, what about if I start in the same spot, I go all the way around, yeah, the circle, and come back and land at that same spot. That's a positive coterminal angle because we start in the same spot and you go up and around, so it's positive. So this is saying if you add a spiral, it'll be a coterminal angle. Okay, let's say I didn't want to add a spiral. Let's say I wanted to find a negative coterminal angle. Well, we start in the same spot. Only negative means go backwards. So let's go backwards. And I want to land in the same spot. So this blue angle is coterminal to this whole purple angle. Let me try that again because those colors were horrible. Okay, so if this is our angle, yeah, coterminal starts at the same spot and backwards to complete that spiral. And it lands at the same spot. So coterminal angles share that terminal side. And we're trying to find basically what's left over from 360. Okay, so first why don't we try a positive coterminal angle, as in an angle that'll land on the same spot? Well, positive means I add 360. If I were to subtract, I'd get a negative angle. So 32 plus 360 is 392 degrees, and that's a coterminal angle. So that would represent this one that went all the way around to spiral and extra. Let's look at this negative coterminal. You're going to take 32 and subtract 360. 330, 328. And I think that makes negative 328 degrees. And that's my negative coterminal angle. That would describe this going backwards almost all the way around. Let's look at 125. Same thing. To find the positive, you take 125 plus 360. To find the negative, you take 125 minus 360. And we get 485 degrees as the positive, negative 235 degrees as the negative. Okay, let's try a different kind of B. Let's say negative 125 degrees. Okay, if I want a positive coterminal angle, I need to either add or subtract 360. Well, let's think to ourselves, what is going to get me a positive angle? If I add 360 or I subtract 360? When I add, so we're going to take negative 125 plus 360. And then for the negative angle, it's going to get even more negative, or like bigger negative, because we subtract 360. So when we add the 360, we should get 235 degrees. When I subtract, I should get 485 again, but it should be negative. Okay, let's look at some pies. For pies, we're going to do the same thing, only instead of adding or subtracting 360, we're going to use the pi equivalent, which the equivalent to 360 or equal to 360 is 2 pi. So to make a positive, we're going to add, what just happened? To make a positive, we're going to add 2 pi. Put my good friend 1 down there. Hey. Multiply by the 7, so we have the same denominator. And we get 2 blah, 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 plus 2 times 7, that's 14. So 2 blah, blah, plus 14 is 16 pi over 7. And that's our positive coterminal angle. Now, let's take 2 pi over 7 and subtract our 2 pi. Hopefully, it's a negative angle. I mean, it is. That was silly. Okay, so anyway, put my good friend 1 down there. Hey. Or ask him to help out. Thank you. And then 2 pi minus 14 pi is negative 12 pi over 7. Whoa. Okay, let's go again. Let's say I start off negative, kind of like I did on part B with negative 125, but I started out with a freakishly big negative. Whew, okay. So to find a positive coterminal angle, we're going to start with this negative 13 pi over 2. And then we're going to go ahead and add 2 pi. Okay, good friend 1, can you help me out? Yes, okay. So we put 1 underneath. We multiply 2 and 2 so that we can get common denominator of 2. And then we get negative 13 pi plus 2 times 2. 4 pi, negative 13 plus 4 is negative 9 pi, all over 2. Is that positive? No. So we have to add again. So we're going to take that negative 9 pi over 2, And we're going to add another spiral because we want a positive coterminal angle. Okay. So we're going to add a spiral. And remember, we have to put my good friend 1 times 2 times 2. That makes, let's see here, -9 plus 4 is -5 pi over 2. But is that positive? Oh, no. So we have to add another 2 pi. Put my good friend 1 times 2 times 2. And we get, let's see, -5 plus 2 times 4 is -1 pi over 2. Is that positive? No. Oh my gosh. So we have to use that -1 pi over 2. And we have to add another spiral because we want a positive angle. And now we get -1 plus 2 times 2. That's 4. -1 plus 2 times 2 is 4. -1 plus 4 is 3. Pi over 2 and hot dog, that's positive. So sometimes you have to add a spiral over and over and over and over. Like on this example we did with the -125. Let's say I started with -729. To get a positive angle, I'd have to say -729 plus 360 over and over. Yeah. Okay. Now let's try negative coterminal angle. Well, we don't have to take this -13 pi over 2 and subtract the 2 pi if we want. We don't have to because we already found tons of negative coterminal angles. So from the left over here, we already found -9 pi over 2. That's a negative coterminal angle. We found -5 pi over 2. That's a coterminal angle. We found -1 pi over 2. Those are all coterminal angles. They all land on the exact same spot. Whether you add 1 spiral, 2 spirals, 18 spirals, or subtract it, whatever. They all land on that same spot. Okay, so coterminal means they share that same little terminal side that you draw. Cofunction means they share the word. Sine, cosine, those are cofunctions. Okay, now we're going to try, I think I'm going to make another video for creating the unit circle. I'm sorry.